All right, let's take a look at the Activity 3 homework, selecting a strategy. In this first triangle, we need to decide whether or not we are going to use our trig ratios or if we're going to use sine law or cosine. This is not a right angle triangle, which means that we're going to be using either sine law or cosine law. To use the sine law, we need to know an angle and the opposite side. And in this triangle, we know angle C and we know side C. So we're going to be able to use the sine law to calculate B. So let's write it this way. Since we're trying to calculate a side length, we're going to use side C over sine of C is going to equal B over sine of angle B. We can substitute what we know. C is equal to 18. Angle C is 53. B is what we're trying to calculate, and angle B is equal to 72. I'm going to rearrange this, and we get 18 times sine 72 divided by sine 53, and that's going to equal B. Punching this in on my calculator, I'm going to get 18 times 72 sine equals divided by the sine of 53. Entering 53 first, and then sine, hit equals, and that means that B is going to be 21.4. All right, let's take a look at the second question. Again, we don't have a right angle triangle, so we're going to be using either our sine law or our cosine law. We're given one angle, but we don't know the side across from it. We don't know anything about the other two angles, so that means we're going to have to use the cosine law. To use the cosine law, we need to know an angle and the side lengths that contain that angle, and we have that. So we're going to use the cosine law in this form. We're trying to solve P, so it's going to be P squared equals Q squared plus R squared minus 2 QR cosine of P. I'm going to plug in what I know. I'm looking for P squared. Q is 23 and R is 12 minus 2 times 23 times 12 times the cosine of angle P, which is 83. I'm going to get my calculator out and calculate P squared. So I'm going to start by entering 23 squared plus 12 squared minus, I want to calculate this all together, so I'm going to use brackets, 2 times 23 times 12 times the cosine of 83. I have to enter in the angle first, and then cosine, close off the brackets, and then hit equals. So that means that P squared is going to equal 605.7. You notice that I kept the number on my calculator. Now I'm going to hit the second function and then square root, and I get an answer of 24.6 for side P. Let's check out the next question. In the next question, we're told that we have a triangle piece of wood, has side lengths 14, 19, and 22. The angle between the two shortest sides needs to be known to see if it will properly fit into a cabinet. So now, let's put the information that we know onto the diagram. We know that the shortest side is going to be 14 centimeters. The longest side is going to be 22 centimeters, and the middle side is 19. And we are asked to find the angle between the two shortest sides. So we're asked to find this angle here. So let's label our triangle with A, B, and C. That means that side A is going to be over here, side B is over here, and side C is over here. This is not a right angle triangle, or it doesn't appear to be a right angle triangle. So that means that we're probably going to have to use our sine law or cosine law, but to use the sine law we need to know an angle and an opposite side. We're not given any angles in this question, so that means that we're going to have to use the cosine law to calculate angle A. To calculate an angle using the cosine law, we need to know all three sides, and we have been given all three sides. So to calculate the cosine of A, I'm going to use the formula B squared plus C squared minus A squared divided by 2bc. I'm going to plug in what I know to calculate cosine of A. B is going to be 19, so 19 squared, plus C is 14, so 14 squared, minus A, which is 22, so 22 squared, all divided by 2 times 19 times 14. I'm going to pull up my calculator, And let's see what we get. So it's going to be 19 squared plus 14 squared minus 22 squared. I'm going to hit the equal sign to figure out what we have in the numerator. Now I'm going to hit divide. I'm going to put this in brackets just to make sure that we carry out all of our multiplication before we divide. So it's going to be 2 times 19 times 14. Close off my brackets and then hit equals. So cosine of A is going to equal 0.1372. Now on my calculator, I'm going to use my cosine inverse function to calculate A. So I use the drop down, second function, cosine inverse, and now I know that angle A has got to be 82.1 degrees to 1 decimal place. All right, moving on to the next question. In the next question, we have a helium-filled advertising blimp. It's attached to the ground using 2 support ropes. One support rope is attached to the middle of the blimp and then down to the ground at an angle of elevation of 38 degrees. The other support is attached to the middle of the blimp again, and it's at an angle of elevation of 46 degrees. The 2 supports are anchored 50 meters apart. So the first thing we need to do is draw a diagram. And we know that the angle of elevation of one of the support lines is going to be 38 degrees. So we'll put that 38 over here at the smaller angle, so 38. And the other angle of elevation of the other support line is going to be 46 degrees. The other thing we're told is the distance between the 2 anchors, so here to here, is going to be 50 meters. The question is, how far above the ground is the blimp? In other words, the perpendicular distance from the ground to the blimp is what we're looking for. We have 2 right angle triangles, and if we knew side lengths of any of the sides in either of these triangles, we would be able to use our primary trig ratios. But we're not given that information. If we can calculate either this side right here or this side right here in the large red triangle, then we can focus in on either one of those 2 right angle triangles and calculate the height, or x. So let's label this. I'm going to label the top as A, B, and C. This point here can be D, but we're not really focused on that right at the moment. And now that I've got the triangle labeled, let's focus on which side we want to calculate. And again, it really doesn't matter if we calculate either AB or AC. Either one's going to work for us. I'm going to calculate AB, and I'm going to label it with a Y. Now the other thing I could calculate fairly easily is angle A up here, because in triangle ABC, those 3 angles, angle A, angle B, and angle C, must add up to 180. We already know that B is 46 and C is 38. Adding those together, we get 84. That means that angle A must be equal to 96 degrees. Because we know angle A and we know the side opposite, we can use our sine law. We're going to be calculating y, which is actually side C. So we're going to use our sine law this way. A over sine of A is going to equal C over sine of C. Substituting in what we know that A is 50. We know that sine A is 96. C is what we're looking for, represented by y, and angle C is 38 degrees. Rearranging this equation to get y by itself, we end up getting 50 times sine of 38 divided by sine of 96 is going to equal y. I'm going to pull up my calculator, and I'm going to start off by typing in 50 times the sine of 38, so 38 and then sine. I'm going to hit equals to see what my numerator equals. Now I'm going to go divided by 96 and again sine. Hit equals, and now I know that y is going to be 30.9526. So I'm going to add that to my diagram, and I can round that to 1 decimal place. So y is going to equal 31.0. And now in triangle ABD, it is a right angle triangle. I know that angle B is 46, which makes this side, which we're trying to find out, the opposite. This is the hypotenuse and this is the adjacent. I can use the opposite and hypotenuse to calculate the height of the balloon. That means I'm going to be using my sine trig ratio, which equals sine of theta over hypotenuse. We know that the angle is 46 degrees. Opposite is what we're looking for, and we just calculated y to be 31.0. Pull up my calculator. I'm going to enter in 46 and then sine times 31.0, hit equals, and now I know the altitude of the blimp is 22.3 meters. All right, let's move on to the last question. And the question says, in order to travel from Alphaville to Capital City, it is necessary to drive through Bartertown on the main highway to avoid a large lake. How much shorter would the drive have been if there was a bridge built to allow people to get from Alpha City to Capital City? Basically what they're asking is, if we had a bridge that went across the lake here, how long would the road from Alphaville to Capital City be? Basically what we need to do is calculate the distance between Alphaville and Capital City, and then we're going to subtract it from 25 plus 17, which is equal to 42, because that's how far you have to drive now. All right, let's take a look at this. To calculate the distance between these two cities, Alphaville and Capital City, we don't have a right angle triangle, which means we can't use our primary trig ratios. We are not given the side opposite the only angle that is given here, so that means we can't use our sine law. The only thing left is to use the cosine law. I'm going to label this triangle with A, B, and C, making this side, side B, this side, side C, and this side, side A. And to find a length using the cosine law, we're going to write our cosine law this way. B squared is going to equal A squared plus C squared minus 2 times A times C, and then cosine of angle B. Plugging in what we know, we're looking for B squared. We know that A is 17, so 17 squared. We know that C is 25, so 25 squared, minus 2 times A, 17, times C, 25, times the cosine of angle B, and angle B is 60. I'm going to pull up my calculator, and we're going to enter this in. So it's going to be 17 squared plus 25 squared minus, now I want to do all this calculation together, so I'm going to use brackets, 2 times 17 times 25 times the cosine of 60. Close off my brackets, hit equals, and I found out that B squared is going to equal 489. Now all I need to do is take the square root of both sides to calculate B, and we get, second function, square root, 22.1. So now we know the distance between Capital City and Alphaville is 22.1 kilometers. Going the other way, it was 42 kilometers going all the way around. So that means if we subtract 22.1 from 42, which will actually give us 19.9, building the bridge will make our route 19.9 kilometers shorter. Sounds like a good deal to me. Build that bridge.